Hi everyone, my name is NatashaNelson. My presentation is titled Applications of Virtual Reality and Augmented Reality in Construction. This review looks into how VR and AR are being used in construction, what benefits are most supported in the literature, what barriers still limit adoption, and what future research should focus on. Today, I'll move through five main areas: background and motivation, the literature collection, the main findings, adoption challenges, and then conclusion and limitation. The guiding question is, are VR and AR being applied in construction, and what benefits, limitations, and future directions emerge from the literature? This section explains why VR and AR matter for construction management. The main issue is that construction is highly visual, highly coordinated, and information heavy. Project teams depend on drawings, models, schedules, reports, and field observations. But that information can be difficult to interpret quickly. VR and AR are useful because they help make project information easier to see, share, and act on. The key ideas here is that VR and AR reduce the gap between project information and field decisions. VR creates a simulated environment where users can rehearse or experience construction conditions before they happen. AR works differently by connecting digital information to real job site conditions. So VR is used for simulation and rehearsal, while AR is used for field-facing information. Both technologies matter because they can help project teams understand complex conditions before those conditions become costly or unsafe problems. I reviewed 20 academic sources published between 2005 and 2024. These include journal articles, conference papers, review studies, prototypes, and case-based studies. The goal was not to summarize each article individually, but to understand what the literature says collectively about VR and AR in construction. The publication chart shows that the sources span from 2005 to 2024, with more activity after 2018. This suggests that the interest in VR and AR has increased as BIM workflows, mobile tools, immersive hardware, and digital construction methods have developed. The word cloud shows the major themes: construction, VR, AR, management, communication, safety, education, productivity, and information. That tells us that the literature is not just about technology, it is about solving construction management problems. To organize the review, I grouped the sources into five categories. The first category maps broad trends. The second focuses on project delivery and visualization. The third focuses on safety, risks, and planning. The fourth focuses on education and training. The fifth focuses on inspection, defects, and productivity. This organization helps shift the review from a list of sources into a synthesis of construction problems. Across these categories, VR and AR are being studied as tools for communication, safety, learning, field support, and decision making. One of the main findings is that VR and AR are related, but they are not interchangeable. VR is strongest when the task requires simulation, rehearsal, or spatial understanding. That includes constructability review, workspace planning, safety training, education, or operation rehearsal. AR is strongest when digital information needs to connect with the physical job site. That includes BIM-based site control, inspection, defect management, risk visualization, and field decision making. The main takeaway is task fit. The technology is most valuable when it matches the construction problem. The benefits of AR and VR are connected rather than just isolated. Better visualization helps users understand space, sequence, and constraints. That improves visualization. That improved visualization can support better communication because teams and clients have a clear shared reference point. From there, VR and AR can support safety and training by allowing hazards and skills to be rehearsed in controlled settings. They can also support inspection and decision making by placing useful information where decisions are made. So the pattern is better visualization leads to better communication, safer planning, stronger training, and better field decisions. Even though the literature is optimistic, adoption is still uneven. The first issue is the prototype gap. Many systems are still classroom-based, case-based, or proof of concept. The second issue is technical integration. These systems need accurate models, reliable hardware, calibration, synchronization, and updated context. Usability is still a major issue. The tools have to work for real users, including field personnel, inspectors, students, managers, and clients. The big question is no longer simply, can VR and AR help construction? The literature suggests they can. The real question is, can scale inside real construction workflow? Can they scale inside real construction workflow? The main conclusion is that VR and AR have strong potential, but their value depends on implementation. VR is strongest for simulation and rehearsal. AR is strongest for real-time field information. Both technologies need to be connected to actual workflows, not treated as standalone tools. The major limitations are usability, scalability, lack of long-term field validation, and limited evidence of measurable project outcomes. Future research should focus on testing VR and AR on active projects, designing around real-time users, integrating with BIM and digital twins, and measuring outcomes like safety, rework, productivity, inspection quality, and coordination. Thank you, everybody. Thank you for listening. Overall, this review shows that VR and AR should not be viewed only as futuristic visualization tools. They are better understood as decision support tools that can help construction teams understand information, communicate more clearly, and make better field decisions. I'd be happy to answer any further questions.